Hi there. Before we begin today's lesson on polynomials, linear factors, and zeros, I really want to suggest you go back to pages, actually 1 through 4, not really just 3 through 4, 1 through 4 of your note packet, because I've introduced this topic and I've used some terminology that I'm going to continue with today. So I want to make sure you remember the terminology, things like squiggle, bounce, end, up, end behavior, those things that I've introduced you're going to need to know. So take the time to reread those pages. And today we're going to talk about writing a polynomial in factored form. So if I give you the expression x cubed minus 2x squared minus 15x, let's remember that it's an expression because there's no equal sign, which means it can't be solved, but we certainly can write it in factored form. So going through our factoring techniques, you remember that the first thing we do is we take out that GCF, greatest common factor. So I notice here that there's a greatest common factor of x. So I take that out and I'm left with x squared minus 2x minus 15. All right, now I see that trinomial that is in the parentheses and I see if I can factor it further. And it appears that I can. So I'm looking at the factors of the 15 or negative 15 that add to negative 2. So I can see probably that it's 5 and 3. And in order for them to add to a negative and multiply to a negative, then the larger term would need to be negative. So x minus 5, and x plus 3. Now, that is factored form, and for now, I'm going to actually call it intercept form. Now, recall that the zeros, or the roots of a function, are the x-intercepts. So if I'm finding the zeros of a polynomial, if I'm asked to find the zeros, the easiest it's easiest when the function is intercept form, okay? So all we need to do then is, if we want to find those x-intercepts or those zeros, is set each factor equal to 0 and solve. So set each factor equal to 0 and solve for x. So in this case, I would make an equation by setting it equal to 0. And then here, each one of these is a factor of the polynomial. So I'd set each one equal to 0 and solve for x. So in this case, I'd get x equals 0, x equals 5, and x equals negative 3. Those would be my zeros, which therefore, as they relate to the graph, would be my x-intercepts. Now, if it's not in intercept form, then you can put it in intercept form by factoring, which is what I just showed you. All right, so how does this relate to the graph? All right, so we're going to add on to what we learned yesterday. First, we're going to find the zeros, and we're going to state the degree of the polynomial. Okay, so let's look at the degree first. Now, yesterday, it was easy for me to find the degree because they were in standard form. You don't want to have to put it in standard form to find the degree. So what I do is I look at how many times x is being multiplied. So it's x here, an x here, and an x here. If I multiply those all out, this is going to end up being x times x times x, which is x cubed. So this is a degree 3 polynomial. Okay, so we know that it's cubic in nature. And remember, the cubic is the one that has the squiggle. Remember, I called that a squiggle. Now that we have the degree, we want to find the zeros. So to find the zeros, we set the factors, because it's in intercept form. We set it equal to 0 and solve for x. Okay? So I'm going to do that down here, sorry. So x equals 0, x plus 3 equals 0, so x equals negative 3, and x minus 1 equals 0, so x equals 1. All right. All right, so let's use that information. So we know that, let's determine the end behavior. So we know that it was a degree 3. And by looking at it, we see that if we do x times x times x, that leading coefficient is going to be positive, okay? Leading coefficient's positive. So a degree 3 graph that with a leading coefficient is a positive number is going to be down up, meaning the end behavior. So end behavior is down up. All right, so we're going to add that one additional component. Now we're going to add in our zeros. So we have a 0 at -3. We have a 0 at 0. And we have a 0 at 1. We know that our behavior is down up, okay? So my graph has to end like that. All right, so we're going to go up through -3, back down to -1 so that I can get this graph going up like that. All right, so let's check that on Desmos. Now on Desmos, guys, you still can put it in the way it's written. So I'm going to do x times x plus 3, and then x minus 1. Now you can see, right now we're just looking at the zeros. It has that 0 at -3, that 0 at 0, and that 0 at 1, that x-intercept. Yes, it goes up a little bit higher, and we're going to talk about how we get those points. This is actually called a relative max up here at the top, and this one's called a relative min. And I am going to be talking about them in the next lesson. But for now, let's just focus on those zeros and the end behavior together. All right, so, oops, sorry about that. All right, so let's put this all together. There's some other things that actually happen on the graph that we need to be aware of, okay? So if I think about that Desmos graph, like how did I know that it went all the way up here? And how did I know that it didn't just stop here and go back down? And so we can actually find that information using what's called the multiplicity of the graph. The multiplicity is the number of factors, so let me get my pen back, the number of times a factor occurs. The number of times a factor occurs. And when we say the exponent, how many times it occurs, it's really the exponent. That tells me how many times it occurs. Okay? The exponent of the factors. And what determines how many x-intercepts the graph of a polynomial is the number of specific factors. What determines the graph's behavior at each x-intercept? It's going to be the factors of multiplicity. So that multiplicity comes into play. The factors multiplicity. All right, so let me put this all together for you. All right, so multiplicity of 1. Now we talked about these terms when we did the basic graphs. A multiplicity of 1, it goes straight through the point. So if you look, I have a factor here of x and an x plus 1. Both of them have their factor's exponent is a 1. So that means it's going to go through the points, okay? So like if I have 2 zeros here and this one's going up, up, it's going to go through the point and then through the point. If it has a multiplicity of 2, okay, sorry about that, it bounces at the point. So you can see here, this has a multiplicity of 2 because that highest factor is a 2. And that means it bounces at the point. And a bounce means something like this. If I had my x-intercept here of -1 and then 1, 2, 3. So there's my intercepts. And I know that this is a cubic function because this is power of 1. So if I multiply the 1s and the 1 and the 2, I get a factor of 3. So the factors, there's 3 factors. That means it's going to be down up. So it's going to go up through 1. Okay, so that has a multiplicity of 1, so it goes through it. Then it's going to turn, but at that multiplicity of 2, it's going to bounce up like that. And I know my graph's not perfect. But that's what a bounce means. So that multiplicity of 2 means that it bounces. It hits it and turns right back around. All right, and the multiplicity of 3 squiggles through the point. We talked about that squiggle before. Now, I see that this graph actually has is a degree of 4. Okay, it's a degree 4 graph. Sorry about that. A degree 4 graph. Why? Because there's a 1 here and a 3 here. That means there's 4 factors. And degree 4 positive graph is going to go up, up. And it looks like I have an x-intercept of -2 and a +3. So -2 and +3. And I'm going to go over how you find these again, so don't worry. So it's up, up. So I know that it's going through 2 because it's a multiplicity of 1. And then it's squiggling through, oops, it's squiggling through that 3, okay? Sorry, my graph didn't come out so good, my squiggle. So let me fix that. Like that. So it squiggles through 3. All right, let's put all this together and let me be clear on each step. I just wanted you to see what it meant between the difference of going straight through, bouncing, and squiggling. Okay, so here's a graph. We need to always look at our degree and therefore our end behavior. I think I left that off, so let's talk about that. Okay, so I first find the degree by looking at all the factors, and I have 1, 2, 3 factors, so that means that it's a degree 3 polynomial, okay? It's positive because none of those factors are negative, so it's a positive leading coefficient, so that means it's going to be, end behavior is going to be down, up, okay? Now, I find my x-intercepts by setting the factors equal to 0, right? So I take this, oops, +2, and x minus 3. I set it equal to 0, and I solve. So I get an x-intercept of x equals 0. So x plus 2 equals 0, so x equals -2. And x minus 3 equals 0, so x equals 3. So there's my x-intercepts. All right, so I'm going to plot those. So I have one at 0, I have one at -2, and I have one at 3. All right, my y-intercept. Now I want to recall y-intercept because this is a recall. To find the y-intercept, set x equal to 0 and solve for y. Okay, so that means, okay, I'm going to set x equal to 0, so 0 times 0 plus 2 times 0 minus 3. And it looks like here 0 times anything is going to give me 0, so y is going to be 0. So my y-intercept is 0, 0. And the multiplicity, I look at all of, x has a multiplicity of 1, so it goes through it. X plus 2 has a multiplicity of 1, so it goes right through it. And x minus 3 has a multiplicity of 1, so it goes right through it. So it's going to go through these points. All right, so now I know it's going down, up, so I'm starting down. I'm going to go through 2. I'm going to turn around, and I'm going to go through 0. And I'm going to turn around so that I'm going up, and I'm going to go through 3. So that ensuring that my graph has a multiplicity of 1, meaning it goes through it, and that it ends down, up. And then I'm going to verify it on Desmos, which I'm going to be asking you guys to do each graph that you do, just to make sure you understand that. So I'm going to put in 2 and 3, and does my graph look like that? Yeah, it does. Now, don't worry about this relative maximum and this relative minimum quite yet. We're going to talk about that again in a future lesson. Okay, so I'm going to stop there today. Tomorrow we're going to be practicing this graphing and the bounce and the squiggle and the going through a point to make sure you understand how to put the end behavior, the zeros, and the multiplicity together. Okay? Have a great day.